Hello students, welcome to my YouTube channel. Today I am going to discuss previous year question series on calculus of variation from the GATE exam. So let's start. So first, what is Euler's equation? What is Euler's equation? Just see, it is very important. What is Euler's equation? That is, suppose the necessary condition for the functional, x0 to x1 f x y y dash dx to be maximized or minimized is that del f del y minus ddx of del f del y dash is equal to 0. So this is called Euler's equation. Okay, del f del y minus ddx of del f del y dash is equal to 0. This is called Euler's equation. Okay, del f del y minus ddx of del f del y dash is equal to 0. So this is called Euler's equation. And what is the alternative form of Euler's equation? The alternative form of Euler's equation is, this can be also, that is, this equation can be also written in the form, this form, that is ddx of f minus y dash del f del y dash minus del f del x is equal to 0. So this is the alternative form of Euler's equation, right? Okay, so now these are very, very important. That is, variational problems becomes meaningless. What are the conditions? Suppose we get the identity when we solve this Euler's equation, del f del y minus ddx of del f del y dash is equal to 0. If we get this 0 is equal to 0 by solving Euler's equation, then the variational problem will be meaningless. Okay, so it is very important. So by solving Euler's equation, what is Euler's equation? That is del f del y minus ddx of del f del y dash is equal to 0. If we solve this equation, we get 0 is equal to 0, then the variational problem will be meaningless. Okay, next, by solving, suppose we get yx by solving Euler's equation, but it does not satisfy the given condition. That is, if the solutions does not satisfy the boundary conditions, then the variational problem becomes meaningless. Okay, ठीक? So by solving Euler's equation, if we get this form, that is 0 is equal to 0 or 1 is equal to 0, something like that, then variational problem will be meaningless. Similarly, by solving Euler's equation, suppose the solution yx does not satisfy the boundary conditions, then the variational problem will also be meaningless. Next, it is very important. If f is independent of y dash, f is independent of y dash, f is a function of, just see, f is a function of, suppose x, y and y dash. If f is independent of y dash, that means del f del y dash is equal to 0. Then what is Euler's equation? We know that this Euler's equation is del f del x del f del y, right, minus ddx of del f del y dash is equal to 0, right? Suppose del f del y minus ddx of del f del y dash is equal to 0. So if f is independent of y, dash, then del f del y dash is equal to 0. So then del f del y, so this equal to 0 because del f del y dash is equal to 0. Just see, if f is independent of y dash, then del f del y dash will be 0. So del f del y dash is equal to 0. Then the Euler's equation, that is, this equation becomes del f del y is equal to 0. So this is not a differential equation. Okay, so we cannot solve further. It is very important. If f is independent of y dash, then by Euler's equation we have del f del y dash is equal to 0. Then Euler's equation becomes del f del y is equal to 0. Hence we cannot solve further since it is not a differential equation. So these are some restriction of variational problem. Okay. So now we discuss, just see this problem. This question asks in GATE exam 2011. Just see this. Assume f to be twice differentiable function, right? And let jy be the functional is of the form that is 0 to 1. What is given here? The functional is integration 0 to 1 f x y dashed f x y dashed dx. Okay, defined on the set of all continuously differentiable function on the closed interval 0 1, that is x belongs to closed interval 0 1. For some arbitrary, here the boundary conditions are y0 is equal to a and y1 is equal to b. That is, at x is equal to 0, the value of y is a, and x is equal to 1, the value of y is b. For some arbitrary constant c, the necessary condition for y to be an extremum, of j. What is the necessary condition? Just see here, just see this form. F is a function of x and y dashed only, right? F is a function of x and y dashed only. So here y absent. That means the function f is independent of y. Just see, x0 to x1, f is a function of x, y, y dashed means dy dx. Then it will be maximum or minimum is that del f del y minus ddx of del f del y dashed is equal to 0. F is a function of x, y, y dashed. So here f is a function of only x and y dash. So y is absent. That means f is independent of y. Okay, clear? That means f is independent of y. F is independent of y. That means del f del y. So this equal to 0, right? Then Euler's equation becomes, what is Euler's equation? That is del f del y minus ddx of del f del y dash is equal to 0. So this is the Euler's equation. So Euler's equation becomes del f del y is equal to 0. That means minus ddx of, so ddx of del f del y dash will be 0. So integrating we get del f del y dash. So this equal to constant. Okay, so if we integrate this, we get del f del y dash is constant. So which option is correct? So option B is the correct answer, right? Okay, clear? Okay, so next problem. Just see this problem. This question asks in GATE exam 2010. The Euler's equation for the variational problem minimize, this is the functional, integration 0 to 1 2x minus xy minus y dashed into y dashed dx is, which is correct? So here just if we compare with the Euler's equation, that is integration x0 to x1, f is a function of x, y, y dash dx. So here f is, this is f, right? So here f is, here f is 2x minus xy minus y dashed into y dashed, right? Okay, that means, so what we get, that is 2x y dashed minus x y y dashed minus y dash square. Okay, so what is Euler's equation? The Euler's equation is del f del y minus ddx of del f del y dash is equal to 0. So this is the Euler's equation. This is Euler's equation. Okay, so this implies that what is del f del y? So therefore del f del y differentiation with respect to y partially. Okay, so this will be 0. Okay, so that means minus x y dashed. Okay, we differentiate f with respect to y partially. So x y dashed is constant, so this is 0, right? So this will be minus x y dashed, and del f del y dashed, del f del y, that is differentiation partially with respect to y dashed. So now x and y are constant, so this will be 2x, right, minus xy minus 2y dashed. Is it clear? Okay, so this is del f del y and this is del f del y dashed. This is del f del y dashed. So now this equation becomes, so del f del y that is minus x y dashed minus ddx of del f del y dash, that is 2x minus xy minus 2y dash is equal to 0, right? So this implies that minus x y dash minus, now just differentiation with respect to x, so this will be minus 2 plus, right? So first x is constant, differentiation of y, that is dy dx, that is y dashed, right, plus y plus 2y double dash is equal to 0, right? Derivative of y dash, that is y double dash, y dash means dy dx, so derivative of dy dx, that is d2y dx2. So this implies that minus xy dash plus xy dash cancel, so 2y double dash plus y, so this equal to 2. Okay, so which option is so which option is correct? So option A is the correct answer. Okay, okay, so next problem, just see this problem. The extremum for the variational problem, this with the boundary conditions. What are the boundary conditions? The boundary conditions are y0 is equal to 0, right, and y pi by 2 is equal to 1. So these are the boundary conditions, okay, occurs for the curve. So basically we have to find the solution with the help of Euler's equation for this functional, right? So here what is f? This is f, right? F is y dashed square, plus 2y y dashed minus 16y square dx. So this is f. Okay, so here f is y dashed square plus 2y y dashed minus 16y square. So this is f. That is, f is a function of x, y, y dashed. Okay, f is a function of x, y, y dashed. So what is Euler's equation? The Euler's equation is del f del y minus ddx of del f del y dashed, del f del y dashed is equal to 0. So this is the Euler's equation. This is Euler's equation. Okay, so now therefore del f del y, that is differentiation partially with respect to y, so 2y dashed minus 32y, so this is del f del y, and del f del y dashed, del f del y dash, so this will be 2y dashed plus 2y, right, 2y dashed plus 2y. Take. So this implies that del f del y, so this is 2y dashed minus 32y minus ddx of del f del y dash, that is 2y dashed plus 2y, so this equal to 0. So this implies that 2y dashed minus 32y minus 2 derivative of y dashed, that is y double dashed minus 2 dy dx, that is y dashed, is equal to 0. So plus 2y dashed minus 2y dashed cancel, right? So ultimately what we get, minus 32y minus 2y double dashed is equal to 0. Just multiplying both sides by minus sign, that is 2y dash plus 32y is equal to 0, dividing both sides by 2, so that means y double dashed plus 16y is equal to 0. So this is the differential equation, right? That means what is the differential equation here? That is d2y dx2, d2y dx2 plus 16y, so this equal to 0. Okay, so now we have to solve this differential equation. So what is the basically this is d squared, right, plus 16 into y is equal to 0. What is d? Basically d means d dx. So what is the auxiliary equation? Auxiliary equation will be m square plus 16 is equal to 0, right? So auxiliary equation is m square plus 16 is equal to 0. That means m is equal to plus minus 4i. So alpha plus minus I beta. So what is the complementary function? That is Cf will be e to the power alpha x, C1 cos beta x plus C2 sin beta x. So therefore Cf, that is complementary function, that is C1 e to the power 0x, C1 cos beta x, C1 cos 4x plus C2 sin 4x. So this is the complementary function. Okay, right hand side is 0, that means pi, that is particular integral, so this is 0. So what is the solution? Y will be Cf plus pi, right? What is the general solution? Y is equal to Cf, that is complementary function, plus particular integral. We know this is the solution. So here, so therefore y is equal to, what is Cf? Cf is C1 cos 4x, C1 cos 4x plus C2 sin 4x. Okay, so this is the solution of the Euler's equation. Okay, now what are the boundary conditions? Just see, here it is given that y0 is equal to 0, right, and y pi by 2 is equal to 1. From these two conditions, we have to find the values of C1 and C2. Okay, so first condition is that y0 is equal to 0, right? So now y0 is equal to 0. That means when x is equal to 0, y is 0. So from this y is equal to 0, x is equal to 0. So C1 cos 0, the cos 0 is 1, C2 sin 0, that is, so ultimately we get C1 is equal to 0. Please correction, this will be y pi by 8. Y pi by 8 is equal to 1. Okay, so again y pi by 8 is equal to 1. That means when x is equal to pi by 8, y is 1. Okay, when x is equal to pi by 8, y is 1. So this implies that y is 1 x is pi by 8. So C1 cos 4 into pi by 8 plus C2 sin 4 into pi by 8. So ultimately what we get? So this will be cos pi by 2, cos pi by 2 is 0. So this will be sin pi by 2, sin pi by 2 is 1, that is C2 is equal to 1. Okay. So C1, so ultimately the value of C2 is 1 and C1 is 0. So the solution becomes, therefore, y is equal to C1 is 0, C2 is 1, that is y is equal to sin 4x. So this is the required curve. So option A is the correct answer. Okay, this question asks in GATE exam 2007. Okay, clear? Just see this problem. Here the functional is given by this. Okay, integration 0 to pi by 2, integration 0 to pi by 2 dy dx square, dy dx square, that means y dashed square minus y square. So what is f? What is f? Here f is, here f is this, that is dy dx square minus y square, dy dx, that is y dashed, so y dashed square minus y square. Okay, so this is f. Take. So f is a function of y and y dashed only. Okay, so f is independent of x, that is del f del x is equal to 0, right? Okay, so now what is Euler's equation? The Euler's equation is del f del y minus ddx of del f del y dashed is equal to 0. The Euler's equation is, what is Euler's equation? Euler's equation is ddx del f del y minus ddx of del f del y dash is equal to 0. Okay, so this implies that del f del y, so therefore del f del y, so this is minus 2y, del f del y dashed, so this is 2y dashed. So del f del y, so this is minus 2y minus ddx of del f del y dash, that is 2y dashed is equal to 0. So that is minus 2y minus 2y dash means dy dx, so derivative of dy dx, that is d2y dx2. So ultimately what we get, that is y double dashed plus y is equal to 0. So this implies that y double dashed plus y is equal to 0. So that is the differential equation is d2y dx2 plus y is equal to 0. That means d square plus 1 into y is equal to 0. So this is the differential equation. Okay, right? So what is the auxiliary equation? Auxiliary equation will be m square plus 1 is equal to 0. So the auxiliary equation is m square plus 1 is equal to 0. Auxiliary equation is m square plus 1 is equal to 0. That means m is equal to plus minus I. So the complementary function CF will be C1 cos x plus C2 sin x. Right hand side is 0, that is particular integral, so this will be 0. So therefore the general solution, that is y is equal to CF plus PI. CF is C1 cos x plus C2 sin x. So this is the solution of the Euler's equation. Okay, C1 cos x plus C2 sin x is equal to 0. Okay, so what are the boundary conditions? The boundary conditions are y0 is equal to 0 and y pi by 2 is equal to 1. Okay. So now from the boundary conditions, now y0 is equal to 0. Now y0 is equal to 0. That y0 is equal to 0. Okay, so that means when x is equal to 0, the the value of y is 0. So from this equation, that means we get 0 c1 cos 0, cos 0 is 1, plus c2 sin 0, that is 0. So c1 is 0. Take. Again from the second boundary condition, that is y pi by 2 is equal to 1, y pi by 2 is equal to 1. That means when x is equal to pi by 2, y is 1. X is equal to pi by 2, y is 1. X is equal to pi by 2, that is c1 cos pi by 2 plus c2 sin pi by 2. Cos pi by 2, that is 0, sin pi by 2, that is 1. So ultimately we get 1 is equal to c2. Take. So the value of c2 is 1 and value of c1 is 0. So therefore y is equal to, c1 is 0, c2 is 1, that is y is equal to sin x. So we get y is equal to sin x. That means which option is correct? That is the corresponding Euler's equation have a unique solution. This satisfy the boundary condition. Just see, y0 is equal to 0, sin 0, that is 0, sin pi by 2, that is 1. So this solution satisfy the boundary conditions. So option B is the correct answer. Okay, right? Okay. So next problem. This question asks in GATE exam 2004. Extremal for the variational problem. This is the functional integration 1 to 2 y square plus x square y dashed square dx satisfy the differential equation. So basically we have to solve the Euler's equation. Right? Okay, so here what is f? This is f. Here f is y square plus x square y dashed square, so this is f. What is Euler's? That is f is a function of x, y as well as y dashed. What is Euler's equation? The Euler's equation is del f del y minus ddx of del f del y dashed is equal to 0. So this is the Euler's equation, right? Okay. So del f del y. So from this del f del y, so this is 2y. Okay. Del f del y dashed. So this is 0. That is x is constant. That is 2x square y dashed. Okay. So this implies that del f del y, that is 2y minus ddx of del f del y dash, that is 2x square y dash is equal to 0. So this implies 2y minus, so first x square fixed, so derivative of y dash, that is y double dash, okay, plus 2y dash fixed, so derivative of x square, that is simply 2x. So ultimately what we get, that is 2y minus 2x square y double dash minus 4x y dash is equal to 0. Okay. So dividing both sides by 2, what we get, that is y minus x square y double dash minus 2 x y dash is equal to 0. Now multiplying both sides by minus sign, so what we get, that means x square y double dash, right, plus 2xy dash plus 2xy dash minus y is equal to 0. So this is the differential equation. Okay, that is x square y double dash plus 2xy dash minus y is equal to 0. So option A is the correct answer. X square y double dash plus 2xy dash minus y is equal to 0. Okay. This question asks in GATE exam 2004. Okay. So next problem. Okay, just see this problem. Extremals y is equal to yx for the variational problem. For the variational problem, integration 0 to 1 y plus y dash square dx. Just see here, f is a function of y and y dash only. That is, f is independent of x. Satisfy the differential equation. So basically we have to solve the Euler's equation. Okay. So here f is equal to, what is f? This is f. Here f is equal to, here f is equal to y plus y dash square. Y plus y dash square. So what is the Euler's equation? The Euler's equation is del f del y minus ddx of del f del y dash is equal to 0. Okay, so del f del y, del f del y, del f del y, that is 2 into y plus y dash. Okay, so del f del y, so this will be 0, this will be 1. Okay, so del f del y is 2 into y plus y dash. So del f del y dash, so this will be 2 into y plus y dash, again differentiation of this with respect to y dash, so this will be 0 and this will be 1. Okay, so del f del y, so this becomes del f del y, that is 2 into y plus y dash minus ddx of del f del y dash, so that is 2 into y plus y dash is equal to 0. So this implies to cancel, right? So that means y plus y dash, okay, minus dy dx, that is y dash, okay, minus derivative of y dash, that is y double dash is equal to 0. Plus y dash minus y dash cancel, so ultimately we get y minus y double dash is equal to 0. That means y double dash minus y is equal to 0. Right? So this is the differential equation. Y double dash minus y is equal to 0. So option B is the correct answer. It's a very easy problem. Okay. So next problem. Just see. On the interval, closed interval 0, 1, here the functional is this, integration 0 to 1 root over of 1 plus y dash, this will be, this is not x, 1 plus y dash square, 1 plus y dash square root over of 1 plus y dash square, okay, divided by x into dx with the boundary conditions y0 is equal to 1 and y1 is equal to 2. So we have to find the differential equation. Okay. Okay. So what is given here? Here f is a function of x and y dash only. This is f. So here f is equal to, here f is equal to root over of 1 plus y dash square divided by x. So this is f. ठीक. What is Euler's equation? Euler's equation is del f del y minus d dx of del f del y dash is equal to 0. F is independent of y. F is independent of y, that means del f del y is equal to 0. F is independent of y. Y is absent, so that is f is independent of y, so del f del y is equal to 0. ठीक. Okay, so we have to calculate del f del y. What is Euler's equation? Euler's equation is del f del y minus d dx of del f del y dash is equal to 0. So this implies that del f del y is 0. Del f del y is 0, right? So that means d dx of del f del y dash is equal to 0. So integrating, what we get? So integrating, we get del f del y dash is equal to constant. Integrating, we get del f del y dash is equal to constant. Suppose c is the integrating constant. So we have to calculate del f del y dash. So del f del y dash. So what is del f del y dash? So del f del y dash. So basically this is 1 plus y dash square to the power 1 by 2 divided by x, right? So n, so differentiation with respect to y dash, so x is constant, right? So n 1 plus y dash square to the power 1 by 2 minus 1, that is this is minus 1 by 2 into derivative of this. So derivative of this, that means 2 y dash. Okay, so ultimately 2 cancel. So what we get? We get y dash, that is 1 by x y dash divided by root over of 1 plus y dash square. Take, so this is del f del y dash. So this implies that del f del y dash is 1 by x y dash by root over of 1 plus y dash square. So this equal to c. Okay, so this implies that y is equal to c x root over of 1 plus y dash square. So this implies that y square, so this equal to c square, so this equal to c square x square into 1 plus y dash square. Okay, this is y dash. So y dash square, so y dash square is equal to c square x square. Okay, so this implies that y dash square is equal to c square x square plus c square x square y dash square. So this implies taking y dash square common, so this will be 1 minus c square x square, so this equal to c square x square y dash square, so 1 minus c square x square, so this equal to c square x square. So option C is the correct answer. Okay, just see options. What we get? We get y dash square into 1 minus c square x square, so this equal to c square x square. Okay, so option C is the correct answer, right? Okay, consider next example. Just see this problem. The extremal of the functional, the extremal of the functional integration 0 to 1 y plus x square plus y dash square divided by 4 into dx with the boundary conditions y0 is equal to 0 and y1 is equal to 0. Okay, here the boundary conditions are y0 is equal to 0 and y1 is equal to 0. We have to extremize this functional. So here what is f? This is f. F is a function of x, y and y dashed. So here f is equal to, here f is equal to, here f is equal to y plus x square plus y dashed square divided by 4. Okay, what is Euler's equation? The Euler's equation is, that is del f del y minus ddx of del f del y dashed is equal to 0. So this is the Euler's equation. This is Euler's equation, del f del y minus ddx of del f del y dashed is equal to 0, right? Okay, so del f del y, so therefore del f del y, so this equal to 1, right? Del f del y dashed, so this will be 0, so this will be 0, that is 2y dashed, that means y dashed divided by 2. Okay, so this implies that del f del y, so this is 1 minus ddx of del f del y dash, that is y dashed divided by 2 is equal to 0. So this implies that 1 minus 1 by 2 derivative of y dashed, that is y double dash. ठीक? So ultimately what we get, that is y double dashed, so this equal to simply 2, right? Y double dashed is equal to 2. Y double dashed means d2y dx2. So d2y dx2 is 2. What is our target? We have to find the value of y, right? That is, we have to solve this differential equation, right? Okay, so now integrating. So integrating we get, so that is y dashed is equal to 2x plus suppose a, while a is the constant of integration, right? Again integrating, that is y is equal to 2 into x square by 2, that is simply x square plus ax plus b. So this is the solution, of Euler's equation. Okay, by solving Euler's equation we get this, y is equal to x square plus ax plus b is equal to 0. Now with the help of initial conditions we have to find the values of a and b. So what are the initial conditions? The initial conditions are y0 is equal to 0, right? So now y0 is equal to, that means when x is equal to 0 the value of y is 0. So this implies that y is 0, x is 0, that is 0 plus b, that is simply b. So we get b is 0. And from the second boundary conditions, again y1 is equal to 0. So this implies that when x is equal to 1, y is 0. From the y is 0, so 0 is equal to, x is equal to 1, so 1 plus a plus b, right? So b is 0, that means a will be minus 1. So a is minus 1, b is 0. So what is the solution? Therefore y is equal to, y is equal to, therefore y is equal to x square plus ax, a is minus 1, plus b, b is 0. So y is equal to x square minus x, right? So y is equal to x square minus x. So this is the answer. So option D is the correct answer. Y is equal to x square minus x, right? So which option is correct? So option D is the correct answer. Clear? Okay. So next problem, just see this problem. It's very important. The possible values of alpha. We have to find the value of alpha. We have to find the value of alpha, for which the variational problem integration 0 to 1 3y square plus 2x cube plus into y dash dx. It is given that this is the boundary condition y1, y alpha is equal to 1, has extremals are minus 1 0 0 1 minus 1 1 minus 1 0 1. So basically we have to find the value of alpha for the following functional. It is given that it has extremal, that is the solution satisfy the boundary conditions. Okay, so here f is equal to, what is f? Here f is this, f is this, right? So here f is equal to, here f is equal to 3y square plus 2x cube y dashed plus 2x cube y dash. So this is f. Euler's equation is, Euler's equation is del f del y minus ddx of del f del y dash is equal to 0. So this is the Euler's equation, del f del y minus ddx of del f del y dash is equal to 0. So this is Euler's equation. So this implies that del f del y, so what is del f del y? Del f del y, so this is 6y, right? Del f del y dashed, del f del y dashed, so this is 0, that means 2x cube. Take, okay. So del f del y is 6y minus ddx of del f del y dash, that is 2x cube is equal to 0. So this implies 6y. So derivative of x cube, that is 3x square. So 6x square is equal to 0. That means x square is equal to y. Y is equal to x square. So this is the solution. Now it has extremal, that means it satisfies the boundary condition, right? A functional will be extremal if the solution satisfy the boundary conditions. So here it has extremal, that means this solution must satisfy these boundary conditions. So what is the boundary conditions here? Here y alpha is equal to 1, right? Y alpha is equal to 1. That means when x is equal to alpha, y is 1. When x is equal to alpha, so alpha square, y is 1. Getting my point? Y alpha is equal to 1. That means when x is equal to alpha, y is 1. X is equal to alpha, that is alpha square, y is 1. So alpha square is equal to 1. That means alpha is equal to plus 1 or minus 1. So which option is correct? The values of alpha will be plus 1 or minus 1. That means option C is the correct answer. Okay, clear? Option C is the correct answer, right? Okay. Next example. Suppose here the functional is Here the functional is integration 0 to 1 f. F is a function of x, y, dy, dx. Dy, dx means y dashed. So f is a function of x, y, y dashed. Satisfying the boundary conditions, y0 is equal to 0 and y1 is equal to 1. Okay. Where f is continuous second order derivatives with respect to its arguments and unknown function y possesses two derivatives everywhere in the open interval 0, 1. If the function depends only on x, if the function f depends only on x and dy dx, if the function depends only on x and dy dx, that means here it is given that f is independent of y. It is given that f depends only on x and y dashed, right? If it is given that f depends on only on x and dy dx, that means y dash. Okay, so we conclude that f is independent of y. It is given that f depends only on x and y dashed, then the Euler's equation is an ordinary differential equation in y in which the general solution is either first order linear equation, first order non-linear equation, second order linear equation, second order non-linear equation. Okay, so f is depends only on x and y dashed, so f is independent of y. Since f is independent of y, so therefore we conclude that del f del y is equal to 0, right? So what is the Euler's equation? Euler's equation is del f del y minus ddx of del f del y dashed is equal to 0. So del f del y is 0. So ultimately we get ddx of del f del y dashed is equal to 0. So integrating we get del f del y dashed is equal to constant, suppose c. Okay, so this is a, in general, so this will be a first order linear differential equation. This will be a first order linear, this cannot be non-linear. This is the first order linear differential equation. Just see, you can check this. See this problem. See this problem. Here f is independent of y, right? F is independent of y. Del f del y is equal to 0. This solution becomes this. So this is the first order linear differential equation. So if f is independent of y, so we get a first order linear differential equation. So option A is the correct answer. Okay, next problem. See this problem. Here the variational problem is integration 0 to 1. This is the functional integration 0 to 1, that is 1 y plus d2y dx2, that means y double dashed. Okay, here the functional is given by integration 0 to 1 y plus d2y dx2, that means y double dashed. Okay, here the functional is y plus d2 by dx2. d2 by dx2 means y double dash. Just see, when functional dependent on higher order derivatives. Note this, functional depends on higher order derivatives. That means suppose f is a function of x, y, y dash, y double dash. F is a function of y, y dash, y double dash. This is the functional integration, suppose x0 to x1, x0 to x1, okay, x0 to x1, right, x0 to x1, this is x0 to x1. So then this functional to be extremum is that del f del y minus del f del y minus ddx of del f del y dash, okay, plus d2 dx2 del f del y double dash is equal to 0. Okay, del f del y minus ddx of del f del y dash minus plus d2 dx2 del f del y double dash. Okay, note this. So the functional this will be extremum is that the necessary condition for the functional to be extremum is that del f del y minus ddx of del f del y dash plus d2 dx2 del f del y double dash is equal to 0. Suppose f is a function of x, y, y dash, y double dash. ঠিক, প্রিভিয়াস যে প্রবলেমগুলো ডিসকাস করলাম, so that is f is a function of x, y, y dash, right? So in that case Euler's equation is del f del y minus ddx of del f del y dash is equal to 0. So here f is a function of, if f is a function of x, y, y dash, y double dash, then this functional will be extremum is that del f del y minus ddx of del f del y dash plus d2 dx2 del f del y double dash is equal to 0. Okay, so note this, the necessary condition for the functional to be extremum is that this. Okay, note this, right? Okay, so come to our problem. So here what is f? F is y plus y double dashed. F is a function, if f is a function of x, y, y dash, y double dash, then what is the equation? The equation will be, that is also called Euler's Poisson equation, that is del f del y, right, minus ddx of del f del y dash plus d2 dx2 del f del y double dash is equal to 0. Okay, so if is a function of, if f is a function of x, y, y dash, y double dash, then this is the Euler's Poisson equation, right? Okay, clear? This is, you can say this is Euler's Poisson equation. Okay, Euler's okay, so here f is independent of, here f is independent of y, f is independent of x, f is independent of x, that is del f del x is equal to 0. F is a function of only y and y dash, so f is independent of x, right? F is independent of y dash also, that is del f del y dash, del f del y dash is equal to 0. f is a function of y and y double dash only. So f is independent of x as well as f is independent of y dash. Okay, so we get del f del x is equal to 0, del f del y dash is equal to 0. So this implies that del f del y, so this implies that del f del y, right, minus del f del y dash is equal to 0. Okay, del f del y double dash, so this is 0, del f del y dash is 0 plus d2 dx2 del f del y double dash del f del y double dash. So differentiation of this, del f del y double dash, that is 1, right, and del f del y, so this is also 1, right. Okay, so del f del y is 1. Okay, this is 0, del f del y dash is 0 plus d2 dx2 del f del y double dash, so this is 1. So ultimately this is 0. So what we get, 1 is equal to 0. So this is absurd, which is absurd, right, which is not possible, which is absurd. So we conclude that the given functional has no extremal. We get this 1 is equal to 0. So this is not possible. So the given functional cannot admit any extremal. Okay, so no extremal. So option D is the correct answer. We see that 1 is equal to 0, so which is absurd. So therefore we conclude that the given functional cannot admit no solution. Okay, so that is the given functional has no extremal. Clear? So the given functional has no extremal. Getting my point? The given functional has no extremal. The given functional has no extremal. So if f is a function of x, y, y dash, y double dash, so we have to apply this result, that is del f del y minus ddx of del f del y dash plus d2 dx2 del f del y double dash is equal to 0. Okay, the necessary condition for the functional integration x0 to x1, f is a function of x, y, y dash, y double dash dx, is that del f del y minus ddx of del f del y dash plus d2 dx2 del f del y double dash is equal to 0. Okay, that is functional depend on higher order derivatives. So we apply this formula, right? Okay, clear? Consider next example. See this problem. The extremum of the functional integration 0 to 1 dy dx square. What is given? Integration 0 to 1 dy dx, that is y dash square plus 12xy into dx. We have to extremize this. If f is a function of x, y, y dash. So what is the Euler's equation? Euler's equation is del f del y minus ddx of del f del y dash is equal to 0. So this is Euler's equation. This is Euler's equation, right? F is a function of x, y, y dash. Suppose if f is a function of x, y, y dash, y double dash, then we have to apply the formula del f del y minus ddx of del f del y dash plus d2 dx2 del f del y double dashed. Okay, if f is a function of x, y, y dashed, y double dashed, that is higher order, so we have to apply this formula del f del y minus ddx of del f del y dashed plus d2 dx2 del f del y double dashed is equal to 0. Okay, so here what is f? So for this problem, here f is, this is f, y dashed square plus 12xy, so this is f, right? So here f is equal to, what is f? Here f is equal to y dashed square plus 12xy. So del f del y, so del f del y, so this equal to, that means 12x, right? Del f del y dashed, so this will be 2y dashed. Okay, del f del y, so this is 12x, and del f del y dash, so this is 2y dashed. Okay, so del f del y, so this is 12x minus ddx of del f del y dash, that is 2y dashed is equal to 0. Okay, so that means dividing both sides by 2, that is 6x minus derivative of y dashed, that is y double dashed is equal to 0. So ultimately what we get, that is y double dashed is equal to 6x, that is d2y dx2, d2y dx2 is equal to 6x. Okay, now simply integration. So integrating, we get y is equal to, so integrating we get, so integrating we get y dash, that is dy dx, so 6 into x square by 2 plus, suppose integrating constant is a, so that is y dash is equal to 3x square plus a. We have to find the value of y, that is we have to solve this differential equation. Okay, so again integrating with respect to x, so again integrating we get y is equal to 3 into x cube by 3, that means simply x cube plus ax plus b. So this is the solution, of this differential equation. Okay, now what are the boundary conditions? The boundary conditions are y0 is equal to 0 and y1 is equal to 0. So first boundary conditions, from the first boundary conditions, now y0 is equal to 0. This implies that when x is equal to 0, y is 0. When x is equal to 0, y is 0. So x is equal to 0, that means this is 0, that means b. So we get b is equal to 0. From the second boundary conditions, y1 is equal to 1 and y1 is equal to 1. So this implies that y1 is equal to 1, right? That means when x is equal to 1, y is 1. X is equal to 1, y is 1. So 1, x is 1. So 1 plus a plus b. It is what we get, b is 0. So this implies a is also 1 cancel, that is a is also 0. So ultimately a is 0, b is 0. So therefore y is equal to x cube. So this is the required extremal. So y is equal to x cube. So which option is correct? So option C is the correct answer. This question asked in GATE exam 2005. Okay, clear? It's easy problem. So next problem, the extremal for the functional integration x0 to x0 to x1 x y dashed plus y dashed square. So f is a function of x y y dashed. So Euler's equation, that is del f del y minus d dx of del f del y dash is equal to 0. So here what is f? So this is f. Here f is equal to, here f is equal to x y dashed plus y dash square. So this is f, right? This is f. Okay, so what is Euler's equation? Euler's equation is that is del f del y minus d dx of del f del y dash is equal to 0. So del f del y. So therefore del f del y, so this will be, here f is, here in f y is absent, that is del f del y is equal to 0, right? Del f del y dashed, so this will be x plus 2y dashed, x plus 2y dashed. Okay, so this implies that del f del y is 0, right? Del f del y is 0. That means what we get? That is d dx of del f del y dash is equal to 0. So this implies that d dx of del f del y dash is x plus 2y dash, right? X plus 2y dash. So x plus 2y dash is equal to 0. That means differentiation of this, that is 1 plus 2 derivative of y dash, that is y double dash is equal to 0. So ultimately what we get, that is y double dash is equal to minus 1 by 2. Y double dash is equal to minus 1 by 2. So this is the differential equation. Okay. Okay, now we have to solve this differential equation. Okay, so integrating, we get del f, that is y dash is equal to minus 1 by 2x, okay, plus suppose integrating constant is c1, okay. Again integrating, that is y is equal to x integrate, that is x square by 4, that is minus x square by 2. So this will be x square by 4 plus c1x plus c2. So this is y. Y is equal to x minus x square by 2, y is equal to minus x square by 4 plus c1x plus c2. So this is of the form this, okay, that is y is equal to minus x square by 2 plus c1x plus c1 c2, it doesn't matter, plus c1x plus c2. Okay, so this is the answer. Option D is the correct answer. Clear? So which option is correct? So option D is the correct answer, right? Okay. Okay, so next problem. The functional, here the functional is integration 0 to 2, okay, integration 0 to 2 y dash square plus 6xy plus x cube, okay, into dx. We have to extremize this function. Okay, I is a function of y. Okay, what are the boundary conditions? The boundary conditions are y0 is equal to 0 and y2 is equal to 2. Can be extremized on the curve. So basically we have to solve the Euler's equation. Okay, so here f is a function of, just see, x y y dashed. F is a function of x y y dashed. So what is Euler's equation? What is Euler's equation? F is a function of x, y, y dash, that is del f del y minus d dx of del f del y dash is equal to 0. So this is the Euler's equation. If f is a function of x, y, y dash, if f is a function of x, y, y dash, then del f del y minus d dx of del f del y dash plus d2 dx2 del f del y double dash is equal to 0, right? If f is a function of x, if f is a function of x, y, y dash, then the Euler's equation is this: del f del y minus d dx of del f del y dash is equal to 0. So this, so what is f here for this problem? Here f is equal to y dash square plus 6xy plus x cube. So therefore del f del y, so therefore del f del y, so this is 0, this is 6x, okay, differentiation partially with respect to y, del f del y dashed, so this is 2y dashed, getting my point, del f del y dash, so this is 2y dashed, okay, so del f del y, so this is 6x minus d dx of del f del y dash, that is 2y dashed is equal to 0. So this implies dividing both sides by 2, that is 3x minus derivative of y dash, that is y double dash is equal to 0. So ultimately what we get, y double dash is equal to 3x, that is d2y dx2 is equal to 3x. We have to solve this differential equation. So integrating, we get dy dx is equal to 3x square by 2 plus integrating constant. So integrating we get, okay, so integrating we get dy dx, that is y dash is equal to 3 into x square by 2 plus integrating constant, suppose a. Again integrating, so what we get, that is y is equal to, so this is 3 by 2 x cube by 3 plus ax plus, suppose integrating constant is b. So ultimately we get the solution of the differential equation is y is equal to x cube by 2 plus ax plus b. Okay, so this is the solution of this differential equation. Now the boundary, with the help of boundary conditions, we can find the values of the arbitrary constants a and b. What are the boundary conditions? y0 is equal to 0 and y2 is equal to 2. So now y0 is equal to 0. Now y0 is equal to 0. So this implies that when x is equal to 0, y is 0. Y is 0 when x is equal to 0. So 0 is equal to, this is 0, this is 0. That means simply b. We get b is equal to 0. And from the second boundary conditions, again from the second boundary conditions, that is y2 is equal to 2. So this implies that when x is equal to 2, y is 2. Y is 2 when x is equal to 2. 2 cube, 8 by 2, that is 4 plus 2a plus b. Here b is 0. So this implies that 2 minus 4, that is minus 2 is equal to 2a. That means a is equal to minus 1. So a is minus 1 and b is 0. So therefore the solution becomes, so therefore y x, that is y is equal to, a is minus 1, right, a is minus 1 and b is 0. So x cube by 2, x cube by 2 minus x, x cube by 2 minus x. So x cube by 2 minus x. So that means 2y is equal to x cube minus 2x. So 2y is equal to x cube minus 2x. So option D is the correct answer. Option D is the correct answer. Okay. So what we get? We get 2y is equal to x cube minus 2x. Right? Okay. So I think clear. Okay. So next problem. It is given that an extremal of the functional integration a to b f is a function of x y dy dx, that is y dash. F is a function of x y y dash. These are the boundary conditions. y1 ya is equal to 1, that is when x is equal to a, the value of y is y1, and when x is equal to b, the value of y is y2. Satisfies Euler's equation, which is in general is a second order linear differential equation, is a non-linear order differential equation, it admits a unique solution satisfying the condition, may not admit a solution satisfying the condition. Option D is the correct answer. May not admit a solution satisfy the given condition. Okay. Euler's equation does not give always a solution. For example, just see this problem. Euler's equation does not give the solution. Okay. So option D is the correct answer. Right? Okay. So today I have discussed all types of problems from calculus of variation based on Euler's equation. Okay. So thank you so much. Bye.